Hi everyone. So today we start a lesson on sequences and specifically how to write formulas for sequences that are called explicit formulas. So sequences is a topic that's going to come up quite a bit throughout the course of Algebra 1, and there's a couple of different ways that we can write formulas for them. So again, today we're kind of just talking about the bare bones basics. We're talking a lot of terminology, notation, things like that. And then later on, I think chapter 3 is the next time this comes back up. We're going to get more into the nitty-gritty of like how do you actually write a formula. So again, today the big focus is just vocabulary and notation. I think it should be pretty easy for you. So here on the screen, I've got 3 different vocabulary words. So if you need to, you can pause the video so that you can get caught up on copying those down, but I'll sort of talk through them right now. So first off, a sequence is any series of numbers, any list of numbers that follows some sort of pattern or a rule. Okay, and again, today we're not talking so much about how to find that rule, but how to use it. All right, so if someone gives you a rule or a formula, how you can use it to generate a sequence of numbers. So the list of numbers is made up of terms, and so the terms are the individual numbers in the list. Okay, so term 5 would be the 5th number in the sequence. And then an explicit formula, and I'm going to get more into that in just a second, but it's when you write a formula for a sequence that relates each term to its term number. Okay, so let's talk more about that. I'm going to get rid of my face because you don't need that anymore. So if you have a formula or a sequence like, let's see, 2, 4, 6, 8, 10, let's say. Okay, that's a sequence of numbers. And so each one of these is called a term, all right? And this would be term 1, this would be term 2, this would be term 3, and so on. So when I write an explicit formula, I want a formula where I can get term 4 based on the fact that it is term number 2. So I want to somehow use the term number to get the term. Okay, so in this particular situation, my terms are generated by doing 2 times the term number. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on. That's what I mean by explicit formula. Okay, so let's dive right into maybe a little bit more complicated example. So these are called the rectangular numbers. Okay, and what I mean by the numbers are, for example, in this array there's 2 dots. In this array there's 6 dots. In this array, let's see, there's 12. In this array there's 20. And so what I want to know is how many would be in the next array. How many, if I drew the next one in that pattern or in that sequence, how many numbers would there be? Well, I would look at this as a pattern. And so at the bottom here, I see I go from 2 dots to 3 dots to 4 dots to 5 dots. So in my next term, I feel pretty good that there's going to be 6 dots across the bottom because I went from 2 to 3 to 4 to 5. And then up the side, I had 1 dot, I had 2 dots, I had 3 dots, I had 4 dots. So now I'm pretty sure there's going to be 5 dots up the side. And I'm not going to take the time to fill all of those in, okay? But if I know that I have 6 by 5, that's going to be 30 dots in the next array, okay? So now, this is where an explicit formula comes into play. It says if this pattern were continued, how many dots would be in the 70th array? Okay, so if you had 70 of these patterns, how many would there be? Well, I certainly don't want to draw that many, okay? So we want to find some way to relate the number 70 to how many dots there would be in the array. So I want you to take a second and think about that, and I think I'm actually going to have that question pop up for you here in a minute. The way I would go about this is I would say, okay, this is term 1, this is term 2, this is term 3, and so on. Okay, so term 1 had 1 dot by 2 dots. Term 2 was 2 by 3. term 3 was 3 by 4. And so if I wanted term 70, I know that up the side there's going to be 70 dots. And across the bottom there's going to be 71 dots. Okay, because every time it increases by 1. So term 1 has 1 here, term 2 has 2 here, term 3 has 3 here, and then along the bottom it always has 1 more than it did going up the side. Okay, so I know that term 70, because of the pattern I've established here, term 70 would have 70 by 71, and I actually don't know how many that would give me. Let's see. 70 by 71 would be 4,970 dots, and I certainly don't want to draw that. Okay, so that's the beauty of an explicit formula, is it allows you to jump straight from the term number down to the actual term, okay, without having to go all the way up. So now let's talk notation, and I'm just going to use this one from before as my example here. So when you see the letter N in terms of sequences, this is always referring to the term number. And when you see this T sub N, that's referring to the actual term. And so, for example, if I had like T5 written, that would be term number 5, okay? And what we want to do in an explicit formula is we always want to somehow get to the term using this term number. So, for example, in these rectangular numbers, I would say I can get any term by taking n and multiplying by 1 more than n, otherwise known as n plus 1, okay? So for term 1, this would be 1 times 2. For term 3, this would be 3 times 4. For term 70, this would be 70 times 71. Okay, that's what this is talking about. So this is what an explicit formula looks like. And that's all it's really saying, is that to get to a particular term, this is what you do with the term number. Okay? And the really important thing about an explicit formula is that it does allow you to jump straight to that term. You can jump straight to term 70 without having to count all the way up to 70. Okay? What we're going to be talking about tomorrow with recursive formulas works a little bit differently. So that's what I want you to keep in mind about explicit formulas. Okay? Okay, so let's do a quick example. It says, consider the formula T sub n equals 5 times n. And there's that notation. So to get to a particular term, you take the term number and multiply by 5. That's what this is saying. Okay? And this piece, the n is greater than or equal to 1, is just saying that's where your terms start. Your first term is going to be term 1, and then you're going to go up from there. So the first 4 terms in the sequence, if I want term 1, I'm going to go 5 times 1, which is 5. Term 2 would be 5 times 2, which is 10. Term 3, 5 times 3, which is 15. And term 4 would be 5 times 4, which is 20. So my sequence would end up looking like this: 5, 10, 15, 20. That's how explicit formulas work. So when it says evaluate T27, I'm going to do 5 times 27, which is, let's see, that's 100. I believe it's 135. And then what does this represent when you see T27? That means that this is the 27th term in this sequence. So if I continued this sequence out to term number 27, this is what it would look like. Okay, that's really it for today for explicit formulas. So go ahead and give the homework a try, and we'll review it tomorrow.